Welcome back to Code and Current Studio. We are continuing with the Arduino vehicle cooling and auto AC system project. In stage 2, we're expanding our system to monitor both cabin temperature and the desired temperature set by the user. We'll display these values on an LCD and prepare the logic for future climate control automation. We are reusing the components from stage 1, the Arduino board, coolant temperature sensor, DC motor, NPN transistor, LCD screen, and the breadboard, and also adding a few new components. Another temperature sensor to monitor cabin temperature, a potentiometer for adjusting the cabin temperature, and another LCD screen. In this stage, we connect the temperature sensor to analog pin A2 to measure the cabin temperature. A potentiometer is connected to analog pin A1 to simulate adjusting the desired cabin temperature setting. The new LCD screen displays both the actual cabin temperature and the desired setting. Each LCD screen must have a unique address. The coolant temperature LCD from stage 1 uses address 0 by 20, while the new LCD in this stage uses address 0 by 21. Additionally, the potentiometer, cabin temperature sensor, and LCD all require connections to power and ground to function properly. Let's take a look at the code. The code reads analog values from the coolant sensor, cabin sensor, and potentiometer. It converts these into Fahrenheit and displays them on the LCDs. The display only updates when the temperature values change, reducing flickering and improving readability. This stage sets the foundation for automated climate control in stage 3. Take a look at our code real quick. Start our simulation. So we can see that the coolant temperature is still displayed from stage 1. If we ramp that up, our fan will come on, and if it's over the 200 degrees, both the yellow and the red LED will illuminate. The new components, we can see here that we've got our cabin temperature and the desired temperature. So cabin is 77 degrees, the desired is 75. So we can say, oh, it's a little hot in the cabin. We can say it's 88 degrees in the cabin while our setting is at 75. We can adjust that. 88 degrees in the cabin, and we desire it to be 70 degrees in the cabin. And this goes between 60 degrees for the lowest setting and 90 degrees for the highest setting. So try adjusting the potentiometer to simulate different desired temperatures. Watch how the LCD updates in real time. Share your ideas in the comments. If you're following along, consider picking up an Arduino starter kit. It includes all the components we've used so far and more to challenge your understanding of electrical systems. Check the description for links to kits and sensors. That is it for stage 2. You've now added cabin temperature monitoring and user input for desired temperature, expanding the system's interactivity and realism. This stage lays the foundation for automated climate control logic in stage 3, where we'll introduce the AC compressor circuit, automated heater cutoff actuator, and add a dynamically controlled blower motor. Keep experimenting and don't forget to like, comment, and subscribe for more Arduino tutorials and project walkthroughs.